So in our previous classes, we discussed forward and backward difference and Lagrange interpolation formula. So in today's class, we are going to be looking at central difference. So we're looking at central difference. We're looking at what central difference. Now pay attention to something. Pay attention that I told you the meaning of interpolation and extrapolation. Do you know the difference between the two? Do you know the difference between interpolation and extrapolation? Do you know the meaning of do you know the difference between the two?
One is inter, the other is extra, like
the word also don't worry. Let me see if we have something like this. Let's say we have pressure and temperature. And what we are having here, let me see, we have 1 atm, 2 atm, 3 atm. And those things were 20, 30, 40. If I ask you to say, find the pressure, no, if I say, find the temperature, if I ask you to find the temperature for me at pressure equal to 2.5, because 2.5 is within this data, that you're having here, then it is what? Interpolation. How's that?
okay.
Good. But if I say find the temperature at pressure equal to 7 atm, you can see that 7 is outside this data. Do you understand?
Yes.
That is what extrapolation. Do you get that?
Yes.
Exactly. So all this formula that we have learned so far, where is it useful now? Pay attention. You see, if you have equal data points, that is data point that have equal difference. For example, like if you see data point that have like, let me say 10, 20, 30, all those data points that have equal difference between themselves. If you look at the one that we have solved before, the one that have equal difference between themselves, if you want to do interpolation for them, it's better we use Newton's interpolation formula for that. For equal data point, yeah. Those ones that always have equal difference here. So we use what? Newton's for that one. But majorly, if you are doing extrapolation, forward difference is very important. So again, for equal difference, we make use of Newton's interpolation. But specifically for if it is not like extrapolation, we use what? Forward difference. But don't worry, we are going to solve number of questions. So that's not a problem. Okay, so let's begin. But if we have unequal data points, what do we use? Lagrange interpolation. You understand?
Yes.
Yeah, whereby we generate polynomial and then we just find what we want to find. And that's all. Okay, let's look at central difference. Now, to solve for central difference, this is the formula we'll make use of. Okay. I'm coming. I want to connect. Stay, I'm asleep. Please hold on. I want to connect. Number. So. All right. Okay, so for central difference, this is the formula we make use of. So we have f of x naught plus mh equal to f of x naught. Look at this formula. Plus we have this combination, m combination 1, delta f of x naught plus m combination 2, delta square f of x naught minus h. Then plus m plus 1 combination 3. Let me put this on here. Plus m plus 1 combination 3. Then what do you have? Delta cube f x naught minus h. Then observe the pattern. M plus 1, 4. Just observe the way the pattern is going. F of x naught. If you observe, x naught occurred twice. After that, we move backward a little. X minus this one occurred twice. Next one, it means that what I'm going to have now was minus 2h. Do you get that?
Yes.
Check. The next one you have, we also have what this kind. Just check the pattern you will see. So this central difference, you see how to get all these things is from the table. So that one is very easy. You don't have to stress yourself. Even if you forget what this formula is, don't worry. Hello, you can forget the formula in this topic. Forgetting the formula is not a wala. If you cannot write the formula out, don't worry. But just note that all these coefficients that are here, we get them from table. And these things are just combination. So you should be able to maneuver your way. Yeah, let's go. Let us solve a particular question. I think we have solved that question before. I'm coming. We have solved that question before. If you can still, if you are with your notes, you will see that we have solved that question before. Where we have x, f of x. How many do you have? 1 to 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. We have solved that question before. I don't know if you can recall these digits. Here, check. 1, 2, 3, 4, 5, 6. I think 4, 14, 40, 88. Check your notes. Are you doing it?
Yes. Yes, sir.
274. Yes. And that asks us to find f of, you don't know f of 2.5. Yes. That's here now. Have you seen it?
It was during interpolation and polynomial.
Yes, that interpolation. Yes, I think look at this particular data. I think I've given you this particular data before. This table, check it. That I see 1 to 6, then 4, 14, 40. That we solved with maybe forward or backward difference. See that of them. Forward difference, yes. Check that forward difference. Was it the one? But it was not the one.
I can't see this data.
Okay, it was not the one.
Okay, yes, I've seen it.
Exactly. What was our answer?
For what?
For this particular
changing.
One. Yes.
The whole answer.
Yes. Okay. But maybe no, maybe you can just check it later. I think the answer is
H. Is it for H?
No, for everything, f of 2.5. I think 24.6%. Abi? 24.625, I think. Yeah, no, let us just move on. Okay, pay attention. What we want to solve is central difference. Abi now?
Yes.
Okay, so let's check our first table. Our first difference. How to do that?
Yeah, can you hear me? I think the one we did was f of 5.5.
Okay, 5.5. Okay.
Yes, it's not
2.5. No. Okay, so let's find our difference. Well, this central difference, you see, you can see some table. You can see some table doing their own difference. In fact, I think, let me help you change this notation. I can change this notation for you as C, because central difference, well, you can see them changing their notation this way. Their notation this way, f of x, but everything, shall know what it means. Yeah, let's go. What do we have? Let me just do our normal notation. So here, wait, let me use what they're using. F of x, delta square, f of x, delta cube, f of x. So yes, so if you like, you can use this. But if you don't like, you can just use our normal. Hello, some textbooks use this. Why? At times, if you like, you can just say, okay, this is your first difference. What else again? This is your first difference, Abina. Then this is your second difference, Abina. Then this is your what? Third difference.
Third difference.
Exactly. So the main thing is that you're able to get the mean value from the table. Yeah. Even if you forget the formula, just note. Oh yeah. How do you find the first difference? Let's go. How do you find the first difference? Oh yeah, first difference. This minus this will give me what? 10, right?
Yes.
So yeah, I have 10. This minus this, I have what? 40 minus 14 will give me what? 36, Abi?
26.
Okay, that's 26.
6. Yes, 26.
Okay, yeah, 26. 26. Next, 48. Next, 76. And the next one, 110. Now, after that, we take another difference again. Secondly, what do we have? 16. This one is 22. This one is 28. This one is 34. Then next, if you minus all of them, we have a constant difference of 666. If you go for that, everything will be 0. Now, pay attention. How do we now get all these values that are here? That's just the main thing that you have here. Yeah, now pay attention. Remember that if it is for forward difference, we just look at 2.5. Okay, 2.5 between this and this. Then we'll go this way. Then we'll now do something like this, right?
Yes.
Yes, that's forward difference. But yeah, the way I'm going to take this is a little bit different. Just pay attention. Remember that 2.5 is a number after these two. Are we together?
Yes.
So see where I'm going to start. So I'm going to do something like this. Like this. Like this. Like this. Do you see?
Yes.
Yes. So from that to that I have there. So you go in that pattern. You go in that pattern. Okay. So you have seen how it is. Master this thing very well. So you're not just going to confuse yourself. Yeah, let's go. Now we want to find f of 2.5. Remember, I will compare whatever I have here to this one. So therefore, I'll be saying x0 plus mh is equal to 2.5. x0 plus mh equal to 2.5. And remember, what's my x0? Remember, that 2.5 you are looking for is between this and this. That's 2.5. So my x0 is 2. So my x0 is 2. So I have 2 plus what is my mh? Look at h. What is h? H is the difference, is the width of this. And you can see that it's constant. Hear what I'm saying? It's constant difference. So that's why we're using Newton's formula. Yeah, let's go. What do we have? Yeah, what's our h difference? That's 1 m equal to 2.5. So therefore, what is my m? M will be equal to what? 0.5, right?
Yes.
So let's go. So it means that my f of 2.5 will be equal to f of x0. What is f of x0? Remember that this guy is my x0. So my f of x0 is 14. So I have 14 plus m combination 1. What is m combination 1? What's m combination 1? It's m. That's m. That's m. And my m is 0.5. M combination 1. M combination 1 is still m. Okay. So my m is 0.5. So I have 0.5. Then times check. What is f of delta f of x? Whatever you are looking for now, this is what you'll be picking. Okay.
Yes.
Do you see the pattern? So that's one that you have there is what? 26. That is everything you are looking for. See, what I are looking for now, delta f of x0 is this 26. This square of this is this 16. And this of this is this 6. Yeah, let's move. Next, m combination 2. What's m combination 2? Do you know? M bracket m minus 1 all over 2 factorial. That's it. That is m bracket m minus 1. That's what? Minus 0.5.
Minus 0.5.
Yes, all over 2 factorial. That's 2. Then times, what do we have? 16. That's why I say if you don't know the formula, you can maneuver your way from here. Very easy. But just practice. Then plus next one, what do we have? M combination what? M combination 3. What would that be? M combination 3. That's what? M bracket m minus 1, m minus 2 over 3 factorial. So let's go. 0.5 times minus 0.5 times what? 0.5 minus 2 minus 1.5.
Minus 1.5.
Exactly. All over what? 6. Then times what do you have? 6.
6.
So let's go. This will give me 14. Plus what's 0.5 times 2? That's times 26. That'll give me 13. That's half of it. So 2 here will give me 8. So what do we have? So 8 of this one will give me minus 2. What am I having here? Give minus 2.
Yes, minus 2. Minus 2. Yes.
Yeah. So I have minus 2. Then 6 will cancel 6. So what I'm having here will give me, I think, minus 0.375. And lastly, the f of 2.5 is going to give me 24.625, and that's it.
0.625.
Yeah, that's how we do it. Just understand the table. If you can understand the table and how to get your values, you are good to go. That's central difference. Do you get that?
Yes.
And lastly, we are looking at the divided difference.
So I just central difference is
What do you say?
I said the central difference means the rest.
It look easier.
Yes.
Wow, that's nice. Nice. It's even good as it is because you see, forward and backward difference, they are too common in a way that they might not even ask you, and then they'll go to central and divided. Yeah, they are too common. Everybody know forward and backward. Yeah, like me. Let me say first or second time I'll be solving central difference and divided because people don't really ask. So focus on them. Divided difference. That one is a little bit time consuming, but we are going to do it. Yeah, let's go. Are you ready? Are you ready?
Yes, I'm ready.
Good. Now, let's see divided difference. What is used for? Well, normally, you can use it for unequal interval. It can work for what? Unequal interval. We can use it for what? Unequal interval. Unequal interval. It can work. Unequal interval. Nice. Now, how do we solve divided? Now, pay attention. If I say, look at this pattern. If I say, what's the divided difference? Check it out. If I say, what is the divided difference of x0, x1? What does that mean? Divided difference of x0, x1. What does that mean? What does that mean? Pay attention. It means f of x1 minus f of x0 divided by x1 minus x0. That is me. You see, this thing means divided difference between x0 and x1. Are we together? All together?
Yes.
Good. Okay. Tell me,
Yes.
if I say, what is the divided difference between, follow this pattern. What is the difference between x2 and x3? What will you tell me?
F of x3 minus f of x2 over x2 minus x3.
Are you sure?
Over x3 minus x2.
X3 minus x2. That's it. Oh yeah, let us extend our idea. What of if I'm asking you to tell me the difference between the divided difference of x0, x1, x2? What would this one tell? What would this one give me? x0, x1, x. Hey, pay attention. See, it will be like this. F of x1, x2 minus f of x0, x1, then divided by x2 minus x0. Observe the pattern very well. Do you see that? F of x1, x2, x0, x1. Check. F of C. Is that like I'm picking this first, then minus this? Do you see that? That's this minus this, then divided by the extreme, x2 minus x1. Exactly. Oh yeah, let us now Look at this
You
pattern.
divided by x2 minus x0.
Yes, x2, yes, that is by the difference between the extreme values, x2 minus x0. Do you get that?
All right.
Yes. But yeah, what if I ask you that? Oh yeah, tell me f of x0, x1, x2, x3. If you can do this, then it is fine. Oh yeah, let's go. Oh yeah, what do we say? Don't forget, pick just like this one. I picked these two, then come back and pick these two. So this one, what will I pick? I'll pick these three altogether. What will I have?
Yes.
F of x1,
So,
x2, x3. Have you seen that?
yes.
Minus f of
F
x0,
of
x1, x2.
x1, x2.
Then divided by
minus x0.
exactly x3 minus x0. Exactly. So as easy as that. That's how we always get. Okay, now if we now have a table now, let me say they give us this table. Let me say they give us this table now, for example. Just as an example. So let's say this is our value of x. This is f of x. Don't forget the pattern. This, this. Yeah, this is x0, x1, x2, and this is x3. Yeah, what will be this one? Remember, this one will be f of x0, f of x1, f of x2, f of x3. Then you see this difference between this divided difference. So whatever we are going to put at this middle will be the divided difference of these two. So it's like I'll be telling that what divided difference of f. See what will be divided difference between x0, comma x1. What will be divided difference between x what x1, comma x2. Have you seen it? Divided difference between x2, comma x3. Do you see that?
Yes.
Exactly. Yeah. Oh yeah, what will not be here? See, what will be here now will not be divided difference of f of x0, comma x1, comma x2. What will not be here what? F of what? x1, x2, x3. Yes. Yes. Then what will not be here what? F of what? x0, x1, x2, x3. Exactly. And to find all this now, to find all this, that's the benefit of all the formula that has been given you here. That's it. So just all these things, or you screenshot them with your phone, because we are going to be using them now.
Sure.
We should move on.
Continue.
Yeah, yes. Nice. Okay, example. Look at this question. One, two. Okay. So here now, the question is this: you have to find f of 6. F of 6. You can see that this, what they're having here now, they are what? On equal interval. Have you now?
Yes.
Exactly, on equal interval. So this divided difference can work for that. And the Lagrange interpolation can also work for that. But yeah, now what do we do? Don't forget, what will be here? Will be what? We are going to find it. Yeah. So the calculation will begin. F of what? X naught comma x1. Remember, is what? F of x1 minus
x1
x
minus
naught.
f of x naught
X1 minus x naught.
x1 minus x naught.
So what's f of x1? See, don't forget. Let me put a label. Let me label this. It's very important. You don't label x naught, x1, x2, x3. So this one is f of x naught, f of x1, f of x2, and this was f of x3. Yeah, let's go. Since that's okay. Yeah, let's go. Oh, so that's I have 5 minus 1. I mean, all over 2 minus 1. And my answer here is 4. So it means that it is 4 you are going to put here like that. 4. Good. So you are going to show this working. Next one, what we are going to put here is what? F of what? X1, comma x2. Yeah, and that's what f of x2 minus f of x1 all over x2 minus x1. So let's go. What's f of x2?
Everything is 0.
F of x2.
5.
Minus f of x1. 5. Okay. That this is what? 0.
0.
Next, what do we have here? I know that f of what?
x2,
x3. Exactly. So that's f of x3 minus f of x2. x3 minus x2. Yeah, what's my f of x3? 4. Minus f of x2. 5. All over what do we have? 8 minus 7 minus 1.
Minus 1.
Minus 1. Nice. And we have gotten that one. Next, we jump to this side. So what do we find here? We want to find what will occupy this side. It was f of what?
F of x naught comma x1 comma x2.
X2. Okay, and that's what f of what? X1 comma x2 minus f of x naught comma x1 all over what? X2 minus x2. You will now see how interesting it will be now. What's my
x2 minus x naught all over x2
minus x naught? Yeah, correct. Yes. Now, what's my f of x1 comma x2? This is 0. You have gotten it.
Yes.
Abina. Exactly. That was 0 minus what's my f of x naught comma x1? That's 4. Abina. You can see just like me saying 0 minus 4. See, if you forget the formula, you can still just go to your table, look at all these things, and just observe the shortcut that you can do. Like, just observe that without the formula going, you observe, oh, it was this number they are using. So you don't even have to put the formula here. Yeah, what's x2 like this now? X2 is what? 7.
X7.
Minus what? X naught is what? 1.
1.
So you observe they said this minus this, then all over this minus this. So that was that does mean. Okay, what would this one give me?
Minus 4 over 6. And that's minus 2.
This person is whining me. Yeah, what do you have there? That's minus 4 over 6, have you?
Yes, minus 4 over 6. That's minus 0.66.
Minus 0. What?
66. How many days?
Let us use it in fraction. What do you have? Yeah, minus 2 over 3, have you?
Yes.
Yeah, next. For this one, what do we have? F of x1, x2, x3. That was f of x2, x3 minus f of x1, x2, x3 minus x1. Yeah, let's go.
So f of x1, x3. Not done that before.
What do you say?
I said we've not done f of x1, x3, so I'm going to keep it down. So that would be.
So what's f of x2, comma x3? That's minus 1.
F of x3 minus 1, yes.
Minus f of x1, comma x2, 0.
Yes.
All over x3 minus x1. What's my x3? 8 minus 1. And that's minus 1 over 7. minus 1 over 7. So lastly,
Magic,
okay.
magic finger. What we said was x3 minus x2. X2 is x3 minus x1 rather. Like f of x2 comma x3 minus f of x1 comma x2 all over x3 minus x1, right?
Yes, that's what I did. Yes.
Yes. So
Okay,
x1.
that's 2.
Yes.
Abi? Yes.
Yes.
Thank you. Thank you
That
for
would
even
be
looking at
over
this thing.
6.
Well, yeah, that's minus 1 over what? 6. Minus 1 over 6, exactly. Minus 1 over 6. Nice. Oh, yeah, lastly, we want to get this one, which is what? F of x naught,
F of
x1.
x1, x1, x2, x3.
Oh, yeah, we already know what the formula will be. We know the formula already.
Yes.
Oh, yeah, what will it be? The F of x1, x2, x3. And it is what? Minus 1 over 6.
Minus 1 over 6.
Minus F of x naught, x1, x2. I mean, and that's what?
Yes,
Minus.
that will become plus 4 over 6.
All over x3 minus x naught. That's 8 minus 1.
Minus 1.
So what would this one give me? Yeah. This will give me minus 1 plus 4 over 6, then all over
7.
This will give me
over 6.
3 over 6. This is game 1 over 2, I mean, and that's 1 over 14.
Exactly.
So this is what 1 over 14. Sharp. We have gotten all this now. Okay. Now, what is now the formula for central difference? Okay, divided difference. I've not even given you. Yeah, the formula for divided difference now. So this is the formula we use. Now pay attention. So for divided difference, our f of x naught. Let me say my f of x is equals to let's go. F of x naught plus x minus x naught. You see all this formula. When it is too much for you, rely on your table and know what you are picking from your table. Then you are good to go. X minus x naught, x minus x1, f of x naught, x1, x2. Yes. Then plus, look at the pattern. Use observe pattern now. X minus x naught, x minus x1, x minus x2, then f of x naught, x1, x2, x3, then plus blah blah blah. So you continue like that. You can see this one have no coefficient. You have coefficient of 1. This one is x minus x naught. Yeah, x naught, x minus x naught, x minus x1. Yeah, to x minus x2. Then to this. Yeah, let's go. Now, what is my f of x naught? Now, what's my f of x naught?
X naught. That's 1.
1, good. So remember that what did you want to find? Hello, this one. Just follow his pattern. Hello. Yeah, we don't say maybe we want to. I'll beat you. We don't say maybe that f of c that we are looking for is between anymore. You see, this one has this formula x1, x2, x3, x4. So whenever I'm looking for f of x1, I'll just pick whatever I'm having here. So just pay attention. See, remember what I'm looking for is what? I'm looking for f of 6. That's what I'm looking for. F of 6 is what I'm looking for. So my x is 6. So I have f of 6. It means that if I don't want to put my 6 directly, I'll have what I'm having here in terms of x, a polynomial. Then you can just put whatever value of x that you want. Yeah, let's go. So f of 6 equal to, let's go. What's my f of x naught? What's f of x naught? 1.
1.
I have 1 plus x minus x naught. That's 6 minus x naught is 1. Then what is f of f of x naught comma x 1? What do I have? 4, Abi? Should you have seen it 4, Abi now?
Yes, x naught comma x 1 minus 5.
You have 4. So you have 4. Then plus 6 minus 1. 6 minus, what's my x1?
5.
2. 2. X1 is 2.
Yes.
Then what's my f of x naught? X1, x2. Minus 4 over 6, Abina.
Minus 2 over 6.
Yes. Then plus, that's the last one. 6 minus 1. 6 minus 2. 6 minus, what's my x2? 7. 7. Hope you get what I'm looking at. X2, that's
Yes,
7.
I was looking at f of x.
Okay, okay. Then what is now my f of blah 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 blah? All this one. That's what? 1 over 14.
1 over 14.
1 over 14. Aha. Yeah, let's solve. So therefore, f of f6. F of 6 is equals to what? What do we have?
1
This is what?
plus 20.
Plus 20.
Yes,
This is 5 times 4. 20. So plus 20 times minus 4 over 6. What would this one give me? This is what? 5 times 4 times minus 1 times 1 over 14. Have you now?
Yes.
Oh, yeah.
21.
This one is 2 here 1. 2 here will give me 3.
Minus
2 here is
3.
minus 40 over 3.
Yes.
And this one 2 here 2. 2 here was 7. Minus 10
minus 10 over 7.
over 7. Oh, yeah, let's use this calculator.
Just a moment.
Okay, no matter. My calculator is not even in this around this side.
Six point two three eight.
6 point what?
6.238.
Our answer is
238.
6.238. Aha. So that is your answer. So that's how we run all this. That's how we run all this. Just simple as that. So you left to just go and practice, like practice. Yes. So that's f of 6. It makes sense. Okay, let me.
What did you say?
No, hold on. Give me a second. I'll check something. Yeah, it's correct. Yes, it's correct. So that's that for that. So our next class, don't forget, we'll be doing what? Do you write that thing down?
Yeah, I snapped it.
So what we'll be doing next, that will be finite difference calculus. Yeah, we have about 2 or how many classes more to go here? So just few more classes, inshallah. Yes. Oh, yeah, no problem. So we'll meet in our next class. So I will send the recording.